Good evening. Today, I'm going to discuss replacement theory, which is a part of second PU statistics unit. And there is a main topic called operational research. Under that, you will get this unit called replacement theory. Now, we all know that fixed assets are of two types. One, assets that deteriorates with life, means there are certain assets, there are certain assets whose value will keep on decreasing longer the time we use. For example, vehicles. So the longer the time we use vehicles, the value of the vehicles will keep coming down. They are called as assets deteriorates with its life. Whereas there are certain assets which appreciates with its life. For example, land. Longer the time you hold this land, the value will keep increasing. So there is a benefit in holding the second category of assets. First category of assets, they're also called as depreciable assets. We know that the word is in accountancy. It is subject to depreciation, so it's called as depreciable asset. So got an idea, fixed assets are of two types called appreciable and depreciable. I hope this is clear. Now my next question is, if I want to give an example like or an instance of assets that deteriorates with its life, let's go for an example of a car. For example, if I buy a car this year, that's in 2021, which is having 15 years life. Now, I have two options. One, should I continue to use till 2025? That means till the end of its 15th year life, should I continue to hold it? Or replace it before 2025? That means buy a new one and sell this old car. Which option is good? Supposing if you say second option is good, if your choice is 2, that is replace it before 25, which so that means buy a new one and sell the old one. Now the question is, why should I do that? Why I should not use it till the end of its life? So in business, we have a lot of reasons for that. Let's see for what reason that one should replace an asset. Because my theory is replacement theory. That means you are not supposed to hold the asset for a longer period. So I have to replace it. Let's see what are the reasons that makes me to replace an asset. So here are the reasons. Reasons for replacement. Point number one. As equipment, generally we call as an equipment, but any asset for that matter, which are depreciable. As an equipment gets older, maintenance cost would be costlier. I hope this you have to agree. For example, when you buy a pet car or scooter, it gives say 60 kilometers per liter. That means if you pay 80 rupees per liter, that you can ride a vehicle for 60 kilometers. If it 4 or 5 years gets older, then the mileage comes down. That means for 1 liter, you will get only 40 kilometers. So maintenance cost will go up, petrol cost will increase. For this reason, you have to replace an asset. Number two, after I buy a car or scooter today, every 6 months, every month, new inventions are there. So new equipments that comes into market would be more efficient and less costly when compared to the old one. So if I buy a scooter for 80,000 rupees in 2021, then in 2023 you will get a new bike for lesser than that. Because of the new inventions, cost would come down. Point number three, new equipment would be superior than the old one because it will have an added features. For example, when we buy a washing machine 10 years ago, it was only top loading. Now we have a front loading. So updation will be there, technological improvements will be there. To get the benefit of that new technological advancement, better you replace it. And the fourth reason, operating cost of new machines would be less than the new one. Sorry, operating cost of new machine would be less in the new equipment. Obviously, because added feature, new technology, cost will be come down. And modern equipments are more beautiful and compact than the old equipment. For example, you might have seen the old calculators and the new one, old watches and smartwatches. So with advancement, you will have more compact and beautiful. For all these valid reasons, better not to use a depreciable asset till the end of its life. Better you sell it earlier to its life is the logic. I hope these 5 points are clear that why one should replace an asset. Now my next question is, okay, fine, we had to replace it, but when? It has a 15 years life. When should I replace it? Now, the theory says that equipments which deteriorates with age is replaced when the annual average cost ceases to decrease and starts increasing. Of course, this is a technical aspect. I'll try to explain now with the help of a graph and then we'll go for a problem on that. Now, this is a graph of the annual average cost. Now, let's suppose this is the year 2012 and on the graph on x-axis. This is x-axis and this is y-axis. So on the x-axis I'm taking years 2021, 2022, 2023, 2024, 2025, 2026. So now on the y-axis I have taken the cost. Now initially cost will be high, 2021, and if you start using it, 2022 cost comes down, 2023 also cost comes down, 2024 also cost comes down. So you can see that initially cost was higher because of the service and other provisions we do for the assets. So its cost comes down. For example, initially when you buy a scooter, probably all of you are having scooter, you will experience that in the first month, for 1 liter it gives only 15 kilometers. So in the second month for 1 liter you will get 30 kilometers, and in the third month you will get 45 kilometers. So you can see that in the first month for 1 liter I'm getting only 15 miles, means my cost is high. In the second month I'm getting 30 kilometers per liter, means cost will come down. I hope you are understanding that. So the cost will steeply decrease year by year and it reaches a vertex here. After this year, the cost will start shooting up. So if you keep any asset beyond this point, then your cost will go up. So I told you this is a annual average cost curve. So as the curve is decreasing and starts declining, so this is the point at which it stops decreasing, ceases to decrease and starts increasing. So if you keep that asset from 2024 onwards, the cost will shoot up. Hence, you must replace the asset in 2024 is optimum replacement age. Don't keep the asset for beyond 24. If you do that, cost will go up. So replacement theory is a theory of cost minimization. If you keep the asset beyond 2024, cost will shoot up. So hence, you're not supposed to keep the vehicle beyond 2006. This is a graphical presentation. I'll show you practically how it's actually possible, why the average annual cost will stop decreasing and starts increasing. We'll see with the help of an example. So you got an idea when to replace. The answer is it should be replaced when the annual average cost curve ceases to decrease and starts increasing. Then you have to replace a set. Now let's see how this is possible. And now, why it ceases to decrease? The next question. I told in the previous slide that it will stop decreasing at 2024, then starts increasing. If you take few reasons, let's think practically. The few reasons why it starts ceases to decrease because its maintenance cost increases after the certain number of years usage. We experience this maximum in scooters and car. And if you're using scooter, the pulling power comes down. Initially, when we get a new bike, usually we go trips, and finally after 3 or 5 years, you will not be the vehicle will not be able to pull the owner only. That means single person. So pulling power has come down, and kilometers per liter comes down. So this will shoot up the cost. As the year passes, you will have a lot of repairs, cost will go up. So because of all this reason, statistical theory says that, operational research says that, don't keep an asset beyond a particular point. What is that point? We try to prove with the help of an example also. So got an idea. These are the reasons why the curve stops decreasing further and starts climbing up after a certain number of years. I hope this point is clear. Now, let's go for an example. How to find out optimum replacement age. Here is a formula that I'll explain this for the time being. So AN stands for this annual average cost. P stands for capital cost of the purchase. And SN stands for resale value. That means the value you will get by selling an asset at the end of each year for n number of years is SN. Summation C is a cumulative maintenance cost for n years. N is a number of years. So based on this formula, we prove that annual average cost will stop decreasing at one point and it starts increasing. So this point is AN, that is the average annual cost stop declining. So this average annual cost is computed with the help of this formula. I explain you this formula with the help of an example. And please note the components. It's P minus Sn plus summation Ci divided by N. Now I have an example for you here. Here I need to add one more point. Cost of the asset. Cost of the asset is rupees 36,000. Okay. Now this example shows that, and also let me add a question. Find optimum replacement age. Replacement age. That means when it should be replaced is the question. And you have the cost of the asset is 36,000 rupees. And the question is that in the first year maintenance cost is 800 and second year it will be 28,000 is a resale value. That means if you use asset for 1 year and throw it away at the end of first year, you can get the asset for 36,000 rupees. Let it be a car instead of saying an asset. I don't think car will get that much of value. But still you can add a car to understand this example. So I paid 36,000 for the car, and if I use it for 1 year and sell, I'll get 28,000 rupees. If I keep using it for the second year also, maintenance cost will be 1,300 rupees for the whole year in second year. And I can sell that car for 22,000 rupees or scooter, whatever it is, for 22,000 rupees. And third year, if I use it, my maintenance cost will be 1,900 and I can sell the asset for 20. You can see that the cost is increasing year by year and the resale values keep coming down. So if you would like to dispose of the asset at the end of sixth year, you will get only 16,000 rupees. So these are the details given. With the help of these details, we are going to compute the previous slide formula. That means the average annual cost. What is the optimum replacement age that we are going to find out? Let's see how to find out. I would like to add here. I don't think I can add in this slide. Okay, here. Let's symbolize it. So we know according to the formula, P is equal to what? Purchase price. Purchase price. What is the purchase price? It is 36,000. And SN is equal to resale value. Resale value. It's given. Resale value is given. Sorry, value. And C indicates maintenance cost. Maintenance cost. So these are the components given in the question. P stands for purchase price, SN stands for the resale value, C stands for the maintenance cost. Now let's see how I can compute the optimum replacement age with the help of the given problem. Now for solving this, I need a table here. I have taken a table with 7 columns. Column and 1, 2, 3, 4, 5 indicates the column numbers. First column is the years. In the second column, P purchase cost 36,000 that remains constant for all the years. SN is the resale value which is given in the question here, the resale value that is kept in this column, that is resale value 28,000 rupees. I'll explain you the column number 4. Column number 5 is a maintenance cost C that is given in this question. Maintenance cost is taken on this column. Now let's see what to do with this table. Now column number 4 is equal to 2 minus, that is P minus SN. It's a component in my formula, you can see here. That is P minus SN I had to calculate. Then I had to calculate summation CI. That should be divided by N. So we are doing this bit by bit in this table. So P minus SN, if you want to get P minus SN, P is in column number 2 and SN is column number 3. If you subtract from column number 2, if you subtract column number 3, that is 2 minus 3, will give you column number 4, that is P minus SN. So 36,000 minus 28,000, you will get 8,000. Correct? And 36,000 minus 22,000, you will get 36 minus 22, you will get 14,000. 36 minus 20,000, you will get 16,000. I'll explain you what is that 8 I'm getting. 36 minus 18, you will get 18,000. And 36 minus 17, 16, 20, 19,000. And 36 minus 17,000, it is 19,000. Now let's see what is this. First year I paid for the car 36,000 rupees, and if I sell it at the end of the first year, I'll get resale value 28,000 rupees. The difference is my loss. Actually, this column, that is P minus SN, actually it's a loss. It's my loss. And if I use a asset for 2 years completely, out of 36,000 rupees, I'll get only 22,000. So what is my loss? 14,000. Similarly, this column, that's column number 4, 2 minus 3, computes your loss to be borne by the owner of the asset. It's a loss. And column number 5 is a maintenance cost given. And summation C, that's cumulative cost you have to compute. Let's see how to compute. First year cumulative will be 800 only. Here. Okay. Now here, Column number 6 computes the cumulative. So first year maintenance cost is 800. For first year summation C will be 800. And please observe, how do I get for the second year? For the second year, you had to add 800 plus 1300. You will get, I'll write in pen only, no problem. It's 2100. Now 2100 plus 1900, you will get 4000. Now 4000 plus 2700, you will get 6700. 6700 plus 3900, you will get 10,600. Then 10,600 plus 5,400, you will get 16,000 rupees. I hope you got this calculation. Now I'll erase this and I'll write it in, I'll type the values for neatness. Okay, now let's go there. So here it's 800 plus 1300, it's 2100, and 2100 plus 1900, it is 4000. 4000 plus 2700, it is 6700. 6700 plus 3900, you will get 10,600. 10,600. 10,600 plus 5,400 will give you 11,000 rupees. This is cumulative cost. I'll explain you what I did now. That means if you hold the asset for 2 years, including the first year's maintenance cost will be 2,100. Similarly, if they use it for 3 years, total maintenance cost will be 4,000. So I'm cumulating, just like you compute cumulative frequency CF, I computed this cumulative cost. This is column number 6. I hope you are clear on column number 4 and column number 6. Now my next column is P minus Sn plus summation C. That is, if you see the formula as the numerator, P minus Sn plus summation Ci. If I do that, so I had to add column number 4, that is P minus Sn. Column number 6 is summation C. If you add these two, you will get 4 plus 6. So now let me add with the help of calculator the values to be obtained there. So it is 8,000 plus 800. It's 8,800. For the second year, how much plus how much? It's 14,000 is P minus Sn plus summation C is 2,100. That gives you 16,100. Then for third year, P minus Sn is 16,000 plus 4,000 is a cumulative cost. So we'll get 20,000. Hope all of you are getting. And for the next year, fourth year, it is 18,000 plus 6,700. It's 24,700. And for the next year, it is for the fifth year, P minus Sn, my loss is 19,000 plus 10,600, 29,600. And for the last year, P minus Sn is 19,000 plus my cumulative cost is 11,000. So I'll get 30,000 rupees is my P minus Sn plus summation C. Now, if I go back to the formula, I got the numerator. P minus Sn plus summation C I obtained. It should be divided by n. What is n? Number of years. So N is in the first column, and seventh column is the numerator. Seventh column divided by first column, that is 7 divided by first column value, will give you the eighth column, that is AN. AN. So now let's divide. Column number 8 is, column number 7 is 8,800 divided by 1. I hope, should I mark? It's this value, this column value divided by this column value. So I'll get 8,800. 8,800. Please observe what happens in the last column. 8,800. Then I'll take you to that graph. Second year, it is 16,100 divided by 2. It is 8,050. What's happening? It is decreasing. Okay, fine. 8,050. Third year, it is 20,000 divided by 3. It is 6,667 or 6. Fine. Then let's see, it has come down. It's coming down. Okay, I'll show you the graph later. Then fourth year, it is 24,700 divided by 4. 6,175. The next year, it is 29,600 divided by 5. 5,920. 920. Then in the last year, 30,000 divided by 6. 30,000 divided by 6. It is 5,000. 5,000. 19,000 last year. If I take 9,000 in the cost, so 10,600 plus 9,000 will give you 19,600. 19,600. Now this 19,600 plus 19,000 will give you 38,600. 38,600. Now 38,600 divided by 6 will give you 6,433. 6,433. Okay. I hope the calculations are clear, except in the last year I made some change to match the theory with the problem. Okay. So if you observe this table, what I computed here, I'll repeat. Column number 2 is asset value. Column number 3 is a resale value. Column number 2, that is P minus SN, will give you the loss. For this, you have to add cumulative cost. You will get the total cost. This divided by 2 will give you AN. This is the average cost. This is average cost. Now, what you have to observe is, please observe. First year, I got AN 8,600, 8,800. Okay, correct. Next year it has still come down. Fine. Next year it has still come down. Next year it has still come down. And also it has come down. Please observe now. So after this 5,920, it should have been lower than this, but it is more than 5,920. That means if you take the graph, which I explained to you already, it looks like this. Cost is decreasing, and it comes to the year, fifth year. After fifth year, it's increasing. So that means this fifth year is a year in which you have to replace that asset. If you keep the asset beyond fifth year, then the cost will shoot up to 6,433. That is what explained in this graph. I'll show you this graph once again. So annual average cost will keep declining, then starts increasing, is practically what happened in the fifth year. This is how we are going to find the optimum replacement age. So now, as the average annual cost ceases to decrease in which year? Fifth year onwards. If you keep this asset fifth year onwards, you have to pay more cost. So cost will shoot up. Hence, you should not use the asset beyond fifth year. At the fifth year end, you have to replace the asset. So this is how a replacement theory is practically utilized in business. And thank you for watching this video. Join for the class more to learn about statistics and all essential component of statistics in the class. Thank you very much.